To make just one jar of honey, bees must visit millions of flowers, work together with 50,000 teammates, and fly a distance equal to twice around the Earth. That single jar represents over 55,000 flight miles, more than most people drive in a year. And it all begins with one insect, the queen bee. From millions of flowers to one jar of honey. This is the hidden process most people never see. Behind this golden liquid is an incredible system powered by billions of bees, expert beekeepers who manage massive colonies across continents, and modern engineering that transforms raw nectar into the perfect breakfast sweetener. But the journey from flower to jar involves dangers, fraud, complex chemistry, and a workforce that never sleeps. Let's go inside. The secret army. Right now, there's a massive workforce operating across the planet, not humans, bees. Beekeepers manage more than 100 million bee colonies worldwide. Each hive contains 20,000 to 60,000 worker bees depending on season. That means trillions of insects working in perfect coordination to produce one of humanity's oldest foods, honey. Global production exceeds 1.9 million metric tons annually, enough to fill over 475 million jars. China produces the most, followed by Turkey, Argentina, Iran, and the United States. But every honey empire begins with one single bee, the queen. The queen, engine of the hive. Inside controlled breeding facilities, beekeepers carefully raise new queens using techniques perfected over centuries. Each queen begins life as a tiny larva, barely visible to the naked eye, smaller than a grain of rice. Beekeepers select larvae from strong colonies with proven traits: high honey production, disease resistance, gentle behavior, and resilience to temperature extremes. Here's where it gets fascinating. Worker bees feed the chosen larva royal jelly. Royal jelly is a nutrient-rich secretion produced by young worker bees. It contains proteins, vitamins, fatty acids, and hormones that trigger dramatic biological changes. Every bee starts with the same DNA, but diet determines destiny. Royal jelly for 12 consecutive days creates a queen, larger, longer-lived, and capable of reproduction. Only 3 days of royal jelly creates a worker bee, smaller, sterile, and programmed for labor. The queen develops in a special queen cell, a vertical, peanut-shaped chamber that hangs from the honeycomb like a stalactite. After 16 days, the queen emerges fully formed. Building a bee colony. When the queen matures, she takes a mating flight, her only time outside the hive as an adult. High in the air, she mates with 10 to 20 male drones from other colonies. This ensures genetic diversity. She stores the sperm inside her body, enough genetic material to last her entire lifetime, which can be 3 to 5 years. Back in the hive, she begins her life's work, laying eggs. During peak season, late spring through summer, a healthy queen lays up to 2,000 eggs per day. That's one egg every 43 seconds, non-stop. Over her lifetime, she may produce more than 3 million bees, replacing workers that die, expanding the colony, and ensuring the hive's survival through winter. The flower fields. Large honey farms manage thousands of hives near massive flowering areas. Clover fields, almond orchards, sunflower meadows, wildflower expanses. Location determines honey flavor, color, and market value. A single worker bee visits up to 5,000 flowers in one day, traveling as far as 3 miles from the hive. But bees don't search randomly. When scouts discover rich nectar sources, they return and perform the waggle dance, a figure-8 pattern encoding distance, direction, and quality. It's a natural GPS system evolved over millions of years. Turning nectar into honey. Nectar collected from flowers is mostly water, roughly 70 to 80% moisture content. That's far too watery to be honey. It would ferment and spoil within days. So bees transform it through 2 critical processes. Process 1. Enzyme addition. As bees collect nectar, they add enzymes from their salivary glands, primarily invertase and glucose oxidase. Invertase breaks down complex sugars, sucrose, into simple sugars, glucose and fructose. Glucose oxidase produces hydrogen peroxide, giving honey its natural antibacterial properties. Process 2. Evaporation. Back in the hive, bees deposit the nectar into honeycomb cells. Then thousands of bees fan their wings in coordinated shifts, creating airflow that evaporates water. This continues for days until moisture content drops to 17 to 18%, the perfect level for preservation. At this point, the nectar has become thick golden honey. Bees seal each cell with a thin wax cap, nature's perfect packaging. Harvest day. Beekeepers monitor hives carefully, waiting for the right moment to harvest. Only fully sealed honeycomb cells can be harvested. If honey is collected too early, it contains too much moisture and may ferment. Beekeepers wear protective suits, full body coverage including veiled helmets, and use smoke to calm bees. Smoke triggers a survival response. Bees think there's a fire, gorge on honey, and become docile. Frames filled with capped honeycomb are carefully removed. Beekeepers must leave enough honey for the bees to survive. Typically, 60 to 90 pounds per hive for winter. Taking too much honey can kill the colony. The dangers of beekeeping. Beekeeping isn't just about harvesting honey, it's about protecting colonies from constant threats. Varroa mites, tiny parasites the size of a pinhead, attach to bees and feed on their blood. Infestations can collapse entire colonies within months. American Foulbrood, a bacterial disease, kills bee larvae and spreads rapidly between hives. Infected colonies must often be burned entirely to prevent contamination. Colony collapse. Disorder, a mysterious phenomenon where worker bees abandon hives, has wiped out millions of colonies globally since 2006. Pesticides, habitat loss, climate change, and poor nutrition all contribute to declining bee populations. Beekeepers must constantly monitor hive health, treat diseases, and manage environmental stressors. Inside the honey factory. Harvested frames arrive at processing facilities, some small-scale operations, others industrial plants processing thousands of pounds daily. Step 1. Uncapping machines or hand tools remove the wax cap sealing each honeycomb cell, exposing the liquid honey inside. Step 2. Extraction. Frames are loaded into centrifuges, large spinning drums that use centrifugal force to fling honey out of the comb without damaging the wax structure. The empty frames can be returned to hives for bees to refill, saving them weeks of wax-building labor. Step 3. Filtration. Raw honey passes through fine mesh screens that remove impurities, wax particles, bee parts, pollen clumps, and debris. Some producers use minimal filtration to preserve pollen, valued for health benefits. Others use ultrafiltration for crystal clear honey. Step 4. Gentle warming. Honey is gently warmed, usually to 95 to 104 degrees Fahrenheit, just enough to make it flow smoothly without destroying heat-sensitive enzymes and beneficial compounds. Overheating destroys honey's natural properties, turning it into glorified sugar syrup. The global honey fraud problem. Honey is one of the most frequently adulterated foods globally. Fraudsters mix real honey with cheap corn syrup, rice syrup, or beet sugar, then sell it as pure honey at premium prices. Estimates suggest up to 75% of imported honey sold in the U.S. is adulterated or mislabeled. Traditional tests struggle to detect modern fraud. Premium producers now use advanced laboratory testing. Nuclear magnetic resonance, NMR, detects added sugars. Pollen analysis verifies geographic origin. Isotope, ratio testing identifies synthetic additives. Authentic honey commands higher prices. Testing proves it's worth it. Bottling liquid gold. After quality checks, honey moves to automated filling lines. Sterilized jars arrive on conveyor belts. Filling nozzles dispense precise amounts, usually 12 ounces, 16 ounces, or 1 pound per jar. Sealing happens immediately to prevent moisture absorption. Labels display honey variety, origin country, grade, and net weight. Jars are packed into cartons and shipped worldwide. Why some honey is extremely expensive. Different flowers produce dramatically different honeys. Clover honey, light, mild, sells for $5 to $8 per pound. Manuka honey from New Zealand sells for over $100 per pound. Why? It contains methylglyoxal, MgO, a compound with powerful antibacterial properties used in medical-grade wound care. Other expensive honeys: Sitter honey from Yemen, Elvish honey from Turkey, harvested 1,800 meters deep in a cave, and life tree honey from Malaysian rainforests. Rarity, medicinal properties, and difficulty of harvest drive prices skyward. The next time you open a jar of honey, remember the incredible journey behind it. The work of 50,000 bees visiting millions of flowers. The expertise of beekeepers protecting colonies from disease and collapse. The precision of modern science ensuring purity and quality. And the 55,000 miles of flight condensed into one golden spoonful.